Okay, so now we're going to start getting a little bit more challenging. It says a 25-foot long ladder is leaning against the wall of a house. The base of the ladder is being pulled away from the wall by an evil cat. Okay, so like joking aside, it says the ladder is moving away from the house. The base of the ladder is. How fast is the top of the ladder coming down, basically? And it gives us a when. So if we look at this as a right triangle, which anytime we have a building and something's leaning against it, we can assume that. So the 25-foot long ladder, that's going to be our hypotenuse here. And the strange thing about this compared to some of the other problems we've done, 25 is not changing. When it's here, it's 25 feet long. When it is, if it was straight up down in the air, it'd be 25 feet long. If it's laying on the ground, it's 25 feet long. It doesn't matter. And anywhere in between, it's 25 feet long. The things that will be changing is how high up on the wall it is, also known as our height, which I could just call y if I want to deal with height. And the other one is the base of it's getting pulled farther and farther away, which we could call x. And so what's really happening is if we think about this triangle, is we're having changing in the x and the y. The x is getting longer, the y is getting shorter. And so we already know our x prime, this 2, is actually a positive number. So we can say x prime, you're positive 2. Y prime, I want to know what you are when the base is 15 feet away. So this is actually basically everything we need, including that 25-foot long ladder, because I can say a squared plus b squared is equal to c squared, since it's a right triangle. And if we take this derivative, we get 2a prime plus 2b prime is equal to 2c prime. And those of you that listen very closely in class, you'll know that I really like that joke, even though it's really dumb. All right, so maybe it's not really dumb, maybe it's just really French. In French, it's abaissé. Anyway, a bunch of you pointed out in class that this is 2 stuff plus 2 stuff is equal to 2 stuff. So I can actually divide both sides by 2 here. And just get a prime plus b prime is equal to c prime. And if we think about these numbers, okay, well, c is 25. Is c changing? Because that's c prime. Whatever c is changing by, that's c prime. No, c is not changing. So c prime is actually 0. So this right-hand side is going to wind up being 0 if you think about that, because it's 25 times 0. Over here, let's see, so at that moment, a is 15, so we know that. I want to know a prime. So maybe this would have been more helpful for me to say x prime plus y prime, kind of keep some consistency with my letters. So I know that, I don't know why. So if I go back and do the Pythagorean theorem, I can say 2 squared plus y squared is equal to 25 squared. That's 4 plus y squared is equal to 25 squared. So I need to solve that, so I'll subtract, 25 squared is 25, go Canfield. Last time I checked, 25 squared is 625. Okay, still 625. So y squared is equal to 625 minus 4, which is 621. And if we take that square root, I believe it's something nice. I'm wrong. Oh my gosh. Just turn the video off. I'm fired. I said that the length of the side was 2. It's not. It's 15. a professional YouTuber would refilm this part. Notice how I'm not refilming this part. So 625 minus 225, 400. So y squared is equal to 400. Take the square root of both sides, we get y is, off camera, y is equal to 20. All right. So now we know everything we need except for y prime, and that's what we want. So I'll subtract the x prime from both sides. I'll divide both sides by y, and we'll get y prime is equal to negative x prime over y. So that's negative x was 15 Canfield, not x prime. X prime was 2, and y was 20. So negative 15 times 2 over 20 is, survey says, 15 over 10? So negative 3/2. And then feet per second. There we go. Feet per second. All right, cool. So slightly more challenging problem. Let's look at the next one. And this one I think is one that really bears an in-depth explanation. So it says a car is traveling due west 50 miles per hour towards an intersection. So if it's traveling due west, which is that way, assuming that never eat soggy waffles is true, so if it's going towards an intersection, that means that if the intersection's here, it's going west, it has to be over here, right? And it says it starts out 200, that's a typo, 200 miles away. And the truck started actually at the intersection. And so the truck's going here. So this is like the beginning. And so we want to know at what rate, so this is like our initial. And then at what rate is the distance between the two, which is, it's the connection, whatever line connects them, after 3 hours. So if you look at the 3 hour mark, if this is going 60, well, 60, 60, 60, that's going to be, it's going to have gone 180, and it's still going up by 60. This guy, who was 200 away, he lost 50 because he got 50 closer, 50 closer, 50 closer. So he's only going to be 50 away now, and he's still getting even closer. Like after 1 more hour, he'll be all the way at the intersection. I don't know what intersection could be so important that this guy is going directly towards it for 4 hours. But anyway, just pretend it's a math problem. So he's going that way at 50 miles per hour. So let's think about the sides of this triangle that gets created here when we look at their distance, which is that line connecting them there. The vertical side is growing. This side is shrinking. And so if we were, I dropped a writing utensil. Oh no, when it fell into the black hole on the floor, it rolled like 5 feet away from me. Okay, no more in that color. So in this situation, this side is growing. So like if I called the bottom side A, so we're gonna have a when A is equal to 50 and when B is equal to 180. But we want, maybe I can call that C. We want C prime. So I don't know C prime, but I do know A is 50 and B is 180, and that's my when. And I'm secretly going to need to find my C. So we know A prime. A prime is 50, right? Except it's not growing by 50. If it was growing by 50, then it'd be positive. Since it's shrinking by 50, we need to say minus. B prime, it's getting longer and longer and longer and longer. He's getting farther and farther and farther away, so B prime is positive 60. So now if we take this to our Pythagorean theorem and say a squared plus b squared is equal to c squared, and take this derivative, 2a prime plus 2b prime is equal to 2c prime. I'm rushing this step. I think it's pretty self-evident. If you don't understand this step, please let me know. I'll do a much more detailed explanation of why that is what it is. I'll divide everything by 2 and get a prime plus b prime is equal to c prime. And I am going to be solving this for c prime. So we're actually right there. We just divide both sides by c. So a prime plus b prime all divided by c is equal to c prime. So I know A, I know B. I'm going to need C. I know A prime, I know B prime. The only thing I need to find is C. And so if I use the Pythagorean theorem here and I say, well, they're both legs, so 50 squared plus 180 squared is equal to C squared. I like to do stuff in my head and by hand when I can, but 180 squared, I'm not sure. I don't know what 18 squared is. All right, so the square root of 34.9. And remember, this technically is plus or minus the square root of 34,900. But since we're dealing with lengths, we don't talk about lengths as ever being a negative number. And so that's why I can just say I know it's the positive. So now I'll go plug everything in, right? So let's see, that's 50 times negative 50 plus 180 times 60 all over the square root of 34,900, which is, I really don't care. I know that's so like negative to say, but it's like, at this point, it's like, okay, we've gone through all of the analysis and all of the really interesting, at least the parts that are interesting to me, the thought process behind things. So I'm going to say 8,300 over the square root of 34,900, which absolutely there's more simplifying that we could do there. We could get an exact answer, which is definitely the sort of thing that I prefer. But this is absolutely a more helpful number, 44.429 miles per hour. And so since that's positive, that means that this distance here is actually growing. And I asked somebody about that, and they didn't really use the answer to help them interpret that, but I really like what he said. He said, this side is growing faster than this side is shrinking. So that would mean that this distance between the two is going to be growing. If you think about those two things as kind of battling each other, you know, the one's going up and the one's going in. So this guy's like getting closer, this guy's getting farther away. If we think about it as he's getting closer slower than he's getting farther away. So there's kind of this sum that happens of their two rates that as they're battling, the bigger rate is winning out. And at that point, it's winning out by that much. So completely unnecessary to solve this problem, just interesting, worthwhile thing to talk about.